So in this lesson today, we're going to talk about area and volume density. So our objective today is to find area and volume density. So that's what you'll be able to do by the end of the lesson today. So first, area density. When we talk about this, we're talking about how many people can fit in a specific area. So this is a great example here. Notice we have a square area there, we have a square area here, we have a square area back there, and a square area back there. So based on this 4 square area, how many people can fit in that area? That's what area density is all about, okay? So population density in this case has to do with people, obviously, or things, and the area that they can fit within. So basically population density is population per unit area or volume. So it's going to be our population over our area. So example 1 says you can fit 20 people in a 5 by 5 square. Using this ratio, how many people can you fit in a 50 by 50 square? So when we set this problem up, we're going to talk about our population over our area. So that's going to be equal to our 20, that's our people, right? So we're always going to put people on the top, and then we're going to do our 5 by 5 square foot. Okay, so that's what we're going to talk about. So that's going to be 20 over 25. Okay, so then we're going to set that equal to how many people can fit in a 500 by 500 square foot. So again, we're talking about people, so we're going to put our X on the top, and we're going to do our 500 times 500 here. Okay. So when we do that, that's going to give us 20 over 25 is equal to X over 250,000, right? Okay. Now hopefully you remember anytime we have an equal sign right here, we're going to cross multiply. So that's what we're going to do here. So we're going to go 25X is equal to 20 times our 250,000. Okay. So when we do that, that 20 times 250,000 is going to be 5 million, right? And that's equal still to our 25x. So we will divide both sides by 25 to get our x. So divide both sides by 25 here. So x here is going to be equal to 200,000. So basically, based on the ratio that we found, 20 people within a 5 by 5 square, we're going to use this ratio, that's what we did, to find out how many people will fit in a 500 by 500 square, and that's 200,000 people. Okay. So this next problem, I would like you guys to go ahead and attempt it and then come back to me when you're done. So this one says, can 1,500 people fit in a room that is 80 by 80 with an average of 4.5 square feet per person? So this is now, we got our feet on top. So see that 4.5 square feet per person? So that's going to be 4.5 feet per person. Okay, so that means we're going to flip the way that we did this problem. So before we did population over area is people per area, right? This time we're going to flip it. So I'm going to say we're going to do our area of our room, 80 times 80, and divide that by our 1,500. Okay, so that's going to be 6,400 divided by 1,500. So the question is, how many square feet do we have per person based on what we were given here? So what I got when I divided that was 4.26 feet per person. And so it asked us, do we have enough? Can we fit that many people in a room if we're supposed to have 4.5 square feet per person? The answer is absolutely not, no. Because with that much room, we only have 4.26 feet per person when we really need 4.5, okay? So you try to says the area of Alabama is 51,718 square miles, and its population is 4,779,736. The area of Missouri is 69,709 square feet, and its population is 5,988,927. The average state population density is 87.4 people per square mile. How do the population densities of Alabama and Missouri compare to the national average? So what I'd like you guys to do is find out the population density. Now, notice it says population density here. So that means we're going to do, again, population over area. So go ahead and find that for Alabama and Missouri, and let's see how they compare. Pause the video. Go ahead and do that. So for Alabama, we have our population, which was 4,779,736, and we're going to divide that by our area, which is 51,718. So for Alabama, I got 92.4. And then for Missouri, we had 5,988,927 over 69,709. Divide those, and we got 85.9. So then it asks us here, how do the population densities of Alabama and Missouri compare to the national average? Well, obviously, this one is above the national average, and this one is below the national average. Okay? Good job. Okay, so example 2 says a rock band is coming to Georgia for a concert. Rather than having the concert in a building, the band chose to have it in a park. Here's the basic layout of the park. So notice we have the stage up here, and then we have zone 1, zone 2, zone 3. Now, each of these zones has a depth, but it also has a width, okay? So, and in part A down here, it says, and actually it says predictions for each zone too. So in zone 1, it's 2.5 square feet per person. Zone 2, it's 4.5 square feet per person. In zone 3, it's 10 square feet per person, okay? So what we want to do is we want to look at, it says the field's been divided into 3 zones for security purposes. Each zone has been measured in its own and has its own crowd estimate predictions. Based on this information, find the total number of people predicted to attend the concert. So what we need to do is we need to find for each of the zones. So we're going to do zone 1. And on this one, we're going to do our width or our depth, whichever how we want to say that, times the. So we're going to do 75 times 250. And when we do that, we get 18,750. And then it says that in this zone we have 2.5 square feet per person. So we're going to divide that by 2.5, and that's going to give us 7,500 people in zone 1, okay? Then we're going to go to zone 2 here. Let's do it in a different color, okay? So this time for zone 2, we're going to do the same thing, 95 this time times our 250. And that's going to give us 23,750. And for zone 2, it said 4.5, so we're going to divide that by 4.5. And for that zone, we have 5,278. Then we have zone 3. And that's this zone right here. So once again, we're going to do our 75 times our 250. We already know that number. That's 18,750. And this time we're going to divide that one by 10. So we do that, we get 1875, my bad. So it's asking us how many total number of people. So what do we have to do with these 3 numbers? We have to add them together, right? So we're going to add all 3 of these numbers together to get our total. And when I did that, I got 14,653 people. That's what our prediction is that are going to attend the concert. It says the county will be hosting the concert. The county that will be hosting the concert recommends that there be a police officer for every 50 attendees. How many officers will be needed based on your predictions? So we're going to take that 14,653 and we're going to divide that by 50. So when we do that, we get 293 police officers. That's a lot, y'all. I hope that's not true. That's going to be pretty expensive. So to hire them. All right, so that is population density. We have another U try here, so let's go ahead and go to that. It says U try 3. For a certain species of animal to survive, the population density must be less than 15 per square mile. 15 per square miles. The rectangular wildlife preserve measured 20 by 15 miles. Scientists counted 3,740 of the animals. Is there enough area for all the animals to survive? So again, look up here what it says. We must have 15 per square mile, okay? 15 animals per square mile. And here's our area, and there's our animals. So find out what the population density is, and then we'll go from there. So pause the video and go ahead and work it out. So here we have 3,740, and we're going to divide that by our 20 by our 15. Okay, so that's going to be 3,740 divided by 300, and when I did that, I got 12.5. So how does 12.5 animals, it says it must be less than, and that is less than, isn't it? That is less than 15. So is there enough area for the animals? The answer is yes, and that's why right there. Okay. So then part B says, if there is enough area, how many more animals could be moved to the preserve? If there's not enough area, how could you change the 15-mile width of the preserve so that the preserve is large enough? Okay, so how many more animals could we put in there? So basically, we have our X over our 300, right? That's how many. And then that is got to be equal to the 15 over the 1, right? So we want 15 animals per every 1 square mile. So we're going to cross multiply this again here. So that's going to be, X equals 15 times 300. So X equals 4,500. So that's the max number of animals that we could have in there. So now what we want to do with that 4,500 is subtract from it the 3,740 to find out how many more animals we could have. So we could have 760 more animals. Okay? All right. So our next concept for the lesson today is density. And you guys have already dealt with this in chemistry. So basically, a definition of dense is closely compacted in substance. Basically, the denser a substance is, the harder it is, okay? And the less dense it is, the softer it is. So the difference between a marble and a marshmallow. Obviously, a marble is much denser than a marshmallow is, okay? So the formula you guys learned in chemistry was density is equal to mass over volume. And this is another way to look at this, that density is equal to mass over volume, okay? So mass is equal to density times volume. So anytime we're doing this, if we're looking for mass, we could multiply both sides by volume here to get the mass. Density and volume, we just switch these two, just like we did when we were dealing with ratios, sine, cosine, and tangent. Remember how we switched what was on the left and the right here in the denominator? Okay, so we could do that here as well. So, example 5 says, consider the 2 blocks below. Each block has the same volume. Which block has a higher density? Now, looking at the blocks, y'all should be able to tell that block 1 has a higher density than block 2 because we know what density means. However, let's prove that. So, density is equal to mass over volume. So what we're going to do is we're going to do our mass, which is 79.4, and we're going to divide that by 29.8. So when we do that, we get 2.66 grams per centimeter cubed, because this was grams and this was centimeter cubed, okay? So now let's compare that with the other one. So again, our density is equal to mass over volume, and that's equal to 25.4 divided by 29.8. Well, you should already be able to tell that that's less than 1, right? So this one is going to be 0.85, again, grams, because that was grams, and this is centimeters cubed per centimeter cubed, okay? So obviously, block 1 is our answer because it asks us which one has a higher density. So this next one says, a student finds a rock on the way to school. In the laboratory, he determined that the volume of the rock was 22.7 milliliters and the mass was 39.9343. What's the density of the rock? So go ahead and do this one again, remembering that density is equal to mass over volume. Pause the video, go ahead and do it, come back to me when you're done. So on this one, you're going to do your mass, which is here, 39.943, and you're going to divide that by your volume, which is right here, 22.7. This was grams, and this is milliliters, okay? So your answer is going to be grams per milliliter, okay? So when we do that, I got 1.76 grams per milliliter, okay? All right, so example 6 is asking us, it says, given the volume and the density, what is the mass? So I'm just going to set this up the same way we've been doing. Density equals mass, because that way you only have to memorize one formula, okay? Mass over volume, okay? So this time we're given density, that's our 13.33, and that's equal to our volume, which is 600. Actually, let's go ahead and put our units on here so we can cancel them out as we go. Grams per centimeters. Whoops, I'm just having trouble today. Per centimeters cubed, and that's equal to, we're looking for mass, and that's over our volume, which is 600 centimeters cubed. Okay, so how do we get rid of something that's in the denominator? Multiply both sides by it, right? So we're going to multiply both by 600. Now what's going to happen here is we had this would be a centimeters cubed on top, right? So those are going to cancel out. So we're just going to be left with our grams. So we're going to multiply 600 times 13.33. And when I did that, I got that my mass is going to be equal to 7,998 grams. Okay, do the same thing with you. Try 6. Pause the video. Go ahead and do it. Come back to me when you're done. So here's our density again. That's 10.49, and that's grams per centimeter cubed. That's equal to, again, we're looking for our mass, right? So mass over our volume, which is 12.993 centimeters cubed. Once again, you should be able to see that these units are going to cancel each other out, right? Because we're going to multiply by it. So we're going to multiply both sides by 12.993. 12.993. So we multiply that times our 10.49. Whoops. I guess what did I do? That should have been 12.49. Sorry, y'all. Okay. So when we do that, we get 136.297, and this is grams. Okay, that's equal to our mass. Example 7 says, given the mass of 1,500 grams and a density of 0.00222 grams per millimeter cubed, what is the volume? So this time we're given density again. Their density is here, so we're going to go 0.00222 grams per, goodness, I keep doing that, grams per millimeter cubed, and that's going to be equal to, this time, remember it's mass over density, right? So mass is going to be mass over volume. So that's 1,500 grams, and then we're looking for our volume. So hopefully you remember when you have something on the left and something on the right of the equal sign in the denominator, you can switch them. So it means our volume is equal to 1,500 grams divided by 0.00222 grams per millimeter cubed, okay? So what does that mean? What's going to happen to our grams? They're both going to go away, aren't they? Okay, so that's going to leave us our millimeters cubed. So we're going to divide the 1,500 by the 0.00222. It's going to be a pretty big number. So the volume is going to be equal to 675,675.68. And again, this is going to be millimeters cubed. All right, let's see if you guys can do this last one. Pause the video and come back to me when you're done. Here we go again. The density, so that's going to be 5.5 grams per centimeter cubed is equal to, we have our mass, which is 2.3 grams, and that's going to be divided by our volume. Once again, we're going to swap those, right? So we're going to swap the volume in the 5.5. So volume is going to be equal to 2.3 grams divided by 5.5 grams per centimeter cubed. Once again, hopefully you can see that your grams are going to cancel each other out. So when we divide 2.3 by 5.5, our volume is going to be equal to 0.4182, and this is again going to be centimeters cubed because that's the only unit we have left.